Alright, so today we are going to take those one-step problems that we did last time, going from grams to moles, moles to grams, moles to particles, and particles to moles, and combine them and make two-step problems. So a quick refresher from last class. Here we're starting with 6.46 grams and going to moles. So I use my conversion sheet, and going from grams to moles, the molar mass goes on bottom, which I get from the periodic table, and 1 mole goes on top. So in this problem, I'm going to divide to get my final answer of 1.62 moles. If I want to take this moles then and convert it to particles, that's again a one-step problem. From moles to particles, I'm going to use the value 6.02 times 10 to the 23rd, also called Avogadro's number. And if I'm starting with 1.62 moles and going to particles, that value 6.02 times 10 to the 23rd is going to go on top, and I'm going to multiply to get my final answer of 9.75 times 10 to the 23rd. Now here it is labeled particles. I need to pick which particle I should label it. So as you can see, I'm working here with helium. That is an individual element. Therefore my particle name is atoms. Remember, my 3 choices for particle names are atoms, molecules, or formula units, with atoms used for single elements, formula units used for ionic compounds, remember, made of a metal and a nonmetal, and molecule used for covalent compounds. So if you don't know what an ionic compound is, it might be worth writing down metal plus nonmetal. It's an ugly plus sign. Metal plus nonmetal. And then covalent compound is nonmetals only. Okay? Covalent compound is nonmetals only. Alright? So make sure you know when you're going to particles what to properly name it. Quick example. KCl. I look on my periodic table, I see it's a metal and a nonmetal, therefore I know it is ionic. So what should I label it? Formula units. Ca, an individual element. There's only one capital letter. Okay? Therefore, I label it atoms. NO, okay? NO2, excuse me. A covalent compound, 2 nonmetals. Therefore, it's labeled molecules. Alright? So when you're going to particles, make sure you know how to label it properly. Okay? And if you need help with that, maybe come see me during HIP. Today's goal. We're going to have the same goal as last time. Really use the mole to convert. Okay? And if you look at your conversion chart, the mole is really the center of all of these conversions. So if you can get to moles, you can go to anything. You can go from grams to particles to liters. Liters is something we haven't yet done. That's also something we're going to add today. Okay? So when you leave here, you're going to be more comfortable with this conversion chart and know how to use it to its full potential. Alright, so let's start with our first example of a two-step problem. Everybody should have out worksheet 6.2. Alright, we should have out again worksheet 6.2, and we're going to start with letter I. Letter I says I'm starting with 11.9 grams of sodium and going to, again, particles, representative particles. So if you want to kind of point to where you're starting, I'm starting at grams, I'm going to particles. So if I look here, there is no one conversion from grams to particles. So it must be a two-step problem. Well, first I must go from grams to moles, and then moles to particles. Okay, I'm going to go from grams to moles, and then moles to particles. So first, to get to grams to moles, I'm going to use the molar mass, and then to get from moles to particles, I'm going to use 6.02 times 10 to the 23rd. So I'm going to start with my 11.9 grams, same as usual. First, I'm going to do this step, 1 mole over the molar mass, which I get from my periodic table. And then I do this step, 6.02 times 10 to the 23rd over 1 mole. Now, what is my particles labeled? Atoms, because it's an individual element. So here, I have a two-step problem. Number other than 1 is on bottom, so I'm going to divide. And then my next step, number other than 1 is on top, so I'm going to multiply. So I take 11.9 divided by 22.99 times 6.02 times 10 to the 23rd, and you should get 3.12. times 10 to the 23rd atoms. So take a second and make sure you can plug that in your calculator. You know how to do it. If not, ask somebody around you. Make sure that, and hopefully they can help you with solving these problems. All right. Next problem. Let's do this one on our marker boards. So why don't you take a minute? Let's pause this video and do this problem on your marker board. So number it 1 and 2. First you're solving for the molar mass, and then you're going from formula units to grams. Alright, so hopefully you've taken a second and got the molar mass of iron 3 oxide. So if I look at this, there are 2 irons and 3 oxygens. To get that molar mass, I take the molar mass of iron times 2 and take the molar mass of oxygen times 3. Now when I add those two together, I get 159.7. There's the molar mass of iron 3 oxide. And I'm going to use that to go from grams, or excuse me, from formula units to grams. So because I'm starting with formula units here, I'm starting in my upper right hand corner of my conversion sheet. And I'm first going to go from formula units to moles. So when I'm going from formula units to moles, I divide by Avogadro's number of 6.02 times 10 to the 23rd, and that gets me to moles. And then from moles to grams, I'm going to multiply by the molar mass. The molar mass of iron 3 oxide being 159.7. So I take 1.23 times 10 to the 24th, divided by 6.02 times 10 to the 23rd, and then multiplied by 159.7. Take a second. Hopefully you've already plugged this in your calculator, but if you have not, please do so. And you should get an answer of 326.3. So here's another good example of a two-step problem, which you're going to have plenty of on your worksheet 6.2. So let's go back to 6.2, do another example from that. Let's do letter J. Letter J, I'm starting with 26.8 grams of C2H2. It says go to particles. Now, if I notice, C2H2 is nonmetals only. So what am I going to call this? I'm going to call it molecules. So I'm starting at grams, and I'm going over here to molecules. Starting at grams, and I'm going over here to molecules. So, very similar to the last problem, going from grams to moles, and then moles to molecules. Alright, if I'm going from grams to moles, I start with 26.8 grams. Looks like the molar mass is going to go on bottom. The molar mass of C2H2, which is 26.04. Where did I get that? Hopefully your answer is the periodic table. That goes on bottom, 1 mole goes on top. That takes me to moles. Next, I'm going to go from moles to particles. To go from moles to particles, 6.02 times 10 to the 23rd goes on top. 1 mole goes on bottom, so I take this 26.8. I divide by 26.04 and then multiply by 6.02 times 10 to the 23rd. And you should end up getting 6.20 times 10 to the 23rd molecules. All right. Let's do one more quick example. This is on the back. Letter R. This is from section 4. So in section 4, you are going to grams. Okay, so in letter R, you're starting at molecules and going to grams. You're starting at molecules and going to grams. So I find molecules on my chart. Here is molecules, and I'm going to grams right here. So if I look, two-step problem. First, I'm going to go from molecules to moles, and then from moles to grams. Alright, so to go from molecules to moles, I divide by 6.02 times 10 to the 23rd. To go from moles to grams, I multiply by the molar mass. So, I take 2.19 times 10 to the 21st molecules, divided by 6.02 times 10 to the 23rd molecules, multiplied by my molar mass. This is a big one. There are 12 carbons. I add that to 22 hydrogens. I add that to 11 oxygens. So when I do that, okay, all of my molar masses times how many of each element there are, I should get 342.34 grams per mole. So here I take 2.19 times 10 to the 21st divided by 6.02 times 10 to the 23rd multiplied by 342.34. what you should end up getting is 1.25 grams. All right, so there's some good examples from worksheet 6.2. It is your job now. Let's take 15 to 20 minutes and finish up 6.2. So please check your answers on the cupboard, and then we are going to go on to 6.3. Go.